Good morning, everyone. In this session, let us discuss the last concept of Unit 1, that is alpha beta pruning. So, this alpha beta pruning is an advanced version of min-max algorithm, and it is also an optimization technique for min-max algorithm. So, coming to this drawback of min-max strategy, that it explores each node in the tree deeply to provide the best path among all the paths, so that it increases its time complexity. But the method used in alpha beta pruning is the cutoff search by exploring less number of nodes, by which without checking each node of the game tree, we can compute the correct min-max decision, and this technique is called as the pruning. So to implement this min-max algorithm, generally we require two threshold parameters that we call it as alpha and beta. So that's why we call this as alpha beta pruning or else alpha beta algorithm. So the two parameters alpha and beta can be defined as this alpha, the best highest value choice we have found so far at any point along the path of maximizer. The initial value of alpha is generally it is minus infinity. Just remember the initial value of alpha will be always minus infinity. Coming to beta, the best lowest value choice we have found so far at any point along the path of minimizer. So alpha is for max and beta is for min. So the initial value of beta is plus infinity. Okay? And for the condition for this alpha beta pruning is the main condition which requires for this is alpha should be always greater than or equal to beta. So whenever we want to prune at some point of time, we should have a condition that alpha should be greater than or equal to beta. And let us see some of the key points about this alpha beta pruning. Here, the very first point is the max player will only update the value of alpha and the min player only will update the value of beta. Alpha value can be updated by only the max player and beta value can be updated by the min player. And one more important point, while backtracking the tree, the node values will be passed to the upper node instead of values and of alpha and beta. That is, when we are backtracking a tree, that means when we are going to the upper nodes, instead of values of alpha and beta, whatever the value at node, only those node values will be passed. And one more important point is, we will only pass the alpha and beta values to child nodes. So when we have a child nodes, we are going to pass the alpha values and beta values. But when we are moving to the upper nodes, only the node values will be passed. These are the two more important points regarding this alpha beta pruning. So let us discuss the working of alpha beta pruning with an example. This is one of the example tree. Let us discuss step by step. The very first step one. At the first step, see this is the diagram, one example. At the very first step, the max player will start the first move from node A, where alpha equal to minus infinity, beta equal to plus infinity. As I already told you, these are the initial value of alpha will be always minus infinity and beta equal to plus infinity. And these values of alpha and beta pass it down to node B, where again alpha equal to minus infinity and beta equal to plus infinity. And node B passes the same value to its child. So now here the D value is my alpha equal to minus infinity, beta equal to plus infinity. Now step 2, now we are at node D. Now the value of alpha will be calculated as its turn for max. Why? Because it is max, then min, then max. So now the value of alpha is compared with firstly 2 and 3. And when we take, as it is max turn, max of 2 comma 3, it will be 3. That means now the alpha value will be changed and now alpha value will at node D will become 3. Okay. Now at step 3, now algorithm backtrack to node B, where the value of beta will change as this is a turn of min. Okay. Now beta equal to plus infinity will compare with the available subsequent nodes. That is, it is going to compare now. It is min term. So min is compared with infinity comma 3. So when we see minimum of infinity and 3, obviously minimum value is 3. So now at node B, alpha equal to minus infinity, it will be same, and beta equal to 3. Okay. Now coming to the step 4. So now in the next step, okay, the algorithm traverses the next successor of B, which is node E. Okay. And the values of alpha equal to minus infinity, beta equal to 3 will also be passed. As I told earlier, when we are moving to the child nodes, alpha and beta values also will be passed to the child nodes. So now here the values will become alpha equal to 5, beta alpha equal to minus infinity, beta equal to 3. Now coming to step 4, at node E, now again it's max turn. Okay. Now here the value of alpha will change. So the current value of alpha will be compared with 5. Okay. So now we have alpha equal to minus infinity. It will be compared with first this side, left side, that is. So max of minus infinity comma 5. So obviously it will be 5. So hence at node E, now alpha value will become 5 and beta equal to 3. And here, see here, alpha equal to 5, beta equal to 3. Okay. Now we met one condition, that is alpha is greater than or equal to beta. Yes, alpha is greater than or equal to beta. So we need not to traverse to the right successor of E. That means we are going to prune the right successor. And now value at node E will be 5. Okay. So here as we met the condition alpha is greater than or equal to beta. So we need not to traverse to the right side of the tree and we can prune it. Okay. So now the node value of E will become 5. I hope till this point you are clear. Now let us see the step 5. Okay. So now in step 5, now algorithm again backtrack to from node B to node A. Now at node A, okay, and see here, it as it is min term, we know that 3 out of 3 and 5, the minimum value will be 3. So beta node value will become 3. Okay. Now we are backtracking from node B to node A. At node A, the value of alpha will be changed. Okay. That is, the available value will become 3. Why? Because, so here as it is max turn, so max of minus infinity comma 3. So it will become 3. And beta will be the same value, that beta equal to plus infinity. Now alpha equal to 3 and beta equal to plus infinity. Now these two values, alpha and beta values, are passed to the C, node C. Okay, these two values now passes to the right successor of A, that is node C. Now at node C, alpha value will be 3 and beta equal to plus infinity. Okay. And the same values will be passed on to the node F. Why? Because we have, there is no value to calculate. So now again these values will be passed to the node F. Now step 6. At node F, okay, again the value of alpha will be computed with the left child, which is 0. That is max of 3 comma 0. Okay, why? Because alpha value is 3 and right left side is 0. So max of 3 comma 0, it will be 3. And then compared with the right child. Okay, and the right child is 1 again. So now this is 3 comma 0, max value will be 3. Now it is going to compare with the right side. So now it is max of 3 comma 1. So out of 3 comma 1, max value will be 3. Still alpha remains same. But the node of F1, F will become 1. Okay. Here, node 0 and 1. So the max value will be 1. So now the node value of F will become 1. See the same points I have explained here in step 5 and step 6. If you didn't understand, just pause for a minute and read thoroughly the step 5 and step 6. Okay. You will get understand. Then see this one. So what I have explained, see alpha equal to and f value will become 1. Now, step 7, okay, till here you are clear. Now, node F returns the node value that is 1 to node C. And now at C, we have already alpha equal to 3 and beta equal to plus infinity. Now, as it is min term, we know that here the beta value will be changed. Now, it will compare with 1. That is, so min of 3, sorry, infinity, comma 1. So, it will be 1. So, now the beta value will become 1 and alpha remains the same, that is 3. Now, again here, there is a condition that it is meeting the condition that alpha is greater than or equal to beta. So when we have this condition, we can prune the right side of this C. That is the this algorithm G we are going to prune it, and algorithm will not compute the entire subtree G. Now C returns the value 1. Why? Because we have only 1 here. So the best value, okay, so here it will become 1. And when it comes to A, here the best value is out of 3 and 1 as it is max term. Yes, of course, max 3 comma 1, it will 3 comma 1, it will be 3. Okay, so this is the final game tree which shows the nodes which are computed and nodes which has never computed. Okay, so these nodes we didn't computed here, and these are the nodes which we have computed. So hence the optimal value for the maximizer is this one. So A to B, that is 3, B to D 3, and here 3. So we can say that the maximum utility value for this one is the 3. So in this way, the alpha beta pruning will work. Okay. Thank you.